Wait, it didn't start yet. Oh, sorry, go ahead.
Hello, everyone. My name is Karen. And then, along my partner Mason, we'll be talking about emotional intelligence comparison among engineering students. This study is conducted for our CE3301 course. Um, so, the project overview. In this study, we aim to explore how emotional intelligence varies among engineering students. We specifically tested for um, work status and academic level. The first hypothesis test we used was a t-test. For this one, we started testing working versus non-working. And then for our second hypothesis test, we used the F-test. And then for this one, we tested the academic level. So on our table of contents, first we'll introduce emotional intelligence, our problem statement, the data collection we use, the first hypothesis test, the second hypothesis test, our challenges, conclusion, the applying of our findings, and then our reference. So what is emotional intelligence? Emotional intelligence is the ability to understand, manage, and respond to emotions, both of our own and others. In engineering, EQ is important because we often work in teams, we lead projects, or communicate with clients. So, having a strong EQ helps us with problem solving, conflict resolution, and career advancement.
All right,
Now,
so I'm
Mason
gonna
will go over the importance of EQ.
yeah. So as my partner said, EQ is very detrimental in industry and career-wise. According to the operational psychologist from the Harvard Business School, uh, working with a colleague who aren't self-aware can cut team success in half. It's very important for optimizing how much work is done in the workforce and how high up and successful you could get in the future. We could see that from a study from the National Institute of Health, higher EQ was directly linked to longer careers, more higher salaries, mostly among engineers, and then the leadership potential. Most leaders, CEOs, stuff like that, have found themselves to prioritize EQ over IQ even. Uh, and there's also the engineering obligation. In the Code of Ethics, Section 1, we are obligated to work for the betterment of our society and stuff like that. So EQ will build a strong moral foundation for us to be able to do that. And then in the next slide, we're going to see that in this study, we're going to test the problem statement. So we're going to look mainly at why the difference between the engineering technical ability and the engineering intellectual ability. So many engineers stereotypically are seen as more withdrawn and introverted, but this could be because the workload for engineers are much harder, so they tend to more focus on technical mastery, and then it could limit their social outings and stuff like that, so they don't develop their EQ as much. So in this study, we plan to explore whether the prior work experience or academic level influences the emotional intelligence of engineering students and examines the social impact employment has on their emotional interpersonal growth.
So to collect your data, we did a survey. Um, we make codes and then links that we share with UTA students. Um, for this, we tested, we did different questions. We did the demographic information, which included the major, academic level, work status, gender, for the EQ related questions. Um, We used 6 different questions for this. One of them was, when I feel strong emotions like stress, excitement, frustration, I can recognize and understand why I'm feeling that way. Um, Mainly, each question tested a different category on the EQ. Some of them was like self-awareness, self-regulation, the empathy, and then the social skills on them. Um, to do the score range of the EQ, we said that if between 24 to 29 points, they will have a high EQ, which demonstrates strong emotional intelligence and interpersonal skills. And then on the lower bound, it was 0 to 10. So they had a low EQ, and they really needed to work on their communication skills, like empathy and recognizing their own emotions. So for the EQ score distribution, we found the mean, which was 20.57 across 78 students that we did the test on. Our mode was 20, the median was 21, our variance was 17.96, and our standard deviation was 4.23. We can see on the graph, on the histogram, we can see that this distribution is skewed left, which indicates that there's a tendency towards higher EQ scores among engineering students. And then now Mason will talk about the first hypothesis test.
Yep. So we chose a t-test for the two sample t-test for the first test because we're trying to see whether the scores between people that have been employed, whether that's full-time or part-time, have any significant change in their EQ score compared to those who have never worked before or are unemployed. So we could see that our null hypothesis is just going to be that there's no difference between them, so therefore they're going to be equal. So our alternative hypothesis is that the working class students have a higher EQ than those who don't. For the sake of the test, we're going to be using a confidence level of 95%, which means that alpha is going to be equal to 0.05. So our variables for the working class, which is going to be N1, everything with a 1 is going to be the working class. We had 49 total responses for that. X1 is going to be, our mean for the working class is going to be 20.65, and our standard deviation is 4.53. And we can see that we got significantly less responses for those who have never worked before. This could be due to the nature of students nowadays. But we got 28 response for that, and then the mean for that is going to be 20.43. Standard deviation is going to be 3.72 or 73. And then in the next slide, we see that using the formula, we got a t-score of 0.2346, which we derived from finding which using with the degree of freedom, which was 75, we got a p-value of 0.41, and then the pooling variance is 4.261. So overall, based on this, the critical value for the 95% confidence interval we found for a one-sided test was 1.668 about. And as we could see in the graph, that our range is significantly like lower than the critical value. Therefore, we had to we failed to reject the null hypothesis. So we couldn't find any significant difference between the EQ with those with work experience and those who don't.
So I'll go over the second hypothesis test. So for this one, we wanted to test whether academic level, specifically being over upperclassmen versus underclassmen, and how like this affects how much EQ scores the EQ score will be higher or lower. For this test, we use an F-test because it compares the variances between two independent groups. So for our null hypothesis, the variance of EQ scores is equal across class level, and then for alternative, upperclassmen have a higher IQ variance than underclassmen. So we can see the formula in there, and then on the left side we can see the data, and then our sample size was 45 for the upper class, and for under was 29. For sample variance was 22.61 for upper, and then for lower was 12.69. We can see that our F-test gave us a result of 1.781. And then our p-value was 0.54. Based on our p-value, we failed to reject the null hypothesis. This will suggest that EQ will not be significantly different. But if you see the graph, they're almost close to each other. So if we were to do an alpha of 10 or 0.10, it will be, we will reject the null hypothesis.
All right, so in the testing stage, we did face a lot of challenges that may have resulted in the results that we got, some biases and such. Because of the way that we collected our data, we collected it mostly through people that we know around us. So there may be some skew because we both have work, so we both may know more people that are employed. We also posted it on online forums such as the UT Arlington subreddit, which may have skewed the data. So we got that unequal sampling size. So our sample population may have not represented the population as a whole. We also had some personal biases. People like to imagine themselves as like better than they might actually be. So they might have gave themselves more favorable scores than truthful scores. We also had a few tests that had either missing information or were incomplete that we couldn't use necessarily, that limited our dataset reliability. And also because of the anonymity of our testing, we're not really sure if there's like any truth in the responses we got, or if we even got students that, or engineering students to respond. It could have just been strangers. So this could have contributed to many inaccuracies in our testing. And then in the next slide, despite this, we could conclude from what we've seen that we found no significant correlation between the employment status of engineering status with their engineering students with their EQ. What this basically means, or it could imply that there's much more factor that goes into EQ, such as the person's upbringing, environment, or their own personal development. In the academic sense of it, so we also did not find any correlation between the variability between underclassmen and upperclassmen. There was no variability. So what that means is there was no uniform way to be able to express EQ. Basically no matter whether you were underclassmen or you're upperclassmen, it was pretty like standard to have a pretty high EQ. Most people like scored around the same range. The variance wasn't very high in any of the tests. That was a fairly tight distribution, which is a great thing actually if you think about it, because these results showing that higher EQ among students is a great indicator for their emotional and social development, which may be great when they go out into industry, meaning they might do like great things for the world, and they're going to be like, you know, caring for the things like environmental problems, political issues, things of that nature.
So how can we apply these findings in our field? So for the first hypothesis, this test really just shows how real work experience can enhance emotional intelligence. And I know our data doesn't really show that working creates a higher EQ. But whenever we compare the average of students who work and go to school versus students that don't work, our average for working students was 20.65, and for non-working students was 20.42. Meaning that it was, even though it's like a slight difference, the average of working students was higher. So this like may encourage some people to like try to look for internships for like part-time jobs to develop your EQ level and your communication skills. For second hypothesis test, mainly it helps us understand the academic level and related to EQ. So sometimes teachers will, at the beginning of our semesters, they will try to emphasize EQ on us. So this kind of help us develop and learning new skills that we'll apply in the future. And in general, the overall impact is that EQ really like helps us at the end of the day to communicate with people and to process better. We can be better engineers. So we can keep growing, not just on the school side, but once we're actually in a workplace, we'll be able to be better leaders, and then just have a team-based like environment, a good team-based environment with our coworkers. So these are references, and then thank you.
Thank you, guys. All right. Good job.
I'll stop for something here, and then